Hi and welcome everyone to Breakpoint. So today we'll be discussing dependency checking with WET. WET is one of the new tools in the market and it is open source. So I highly encourage everyone else. There are some interesting features in WET which we'll be discussing and diving into today. So like others, this is also a tool for dependency checking. We'll have a quick look. We'll start off with a demo to look at how the installation and configuration happens. Then we'll quickly jump into the architecture and how it works. And then look at the findings ourselves. So we'll do a quick analysis in this one video. So let's come out, presentation. So when you look at WET, let me go to So the GitHub for WET, you can directly check out the GitHub for WET, and at that time, while on the Git, you will find most of the resources which are required to actually have WET installed and running for your systems. So initially, you can essentially, this is for vetting, essentially for vetting open source packages. It also supports a lot of languages, including Java, Python and all others. So we'll look into that deeply right now. But before that, check out the GitHub page, and then you can get started there. You can simply download it from there. If you are on Mac, you can download simply by using Brew. It easily downloads the latest version of WET. With the command, you can use Brew install. If you want to actually build it from source, you can do that as well. You will need to have Go in place, and then using Go, you can install that. Now, once you have that installed, it is advisable to also download, or maybe you can just clone. There is a demo repository. If you don't have a set of dependencies of your own, if you're just playing around with it, then you can also download the demo package that is there on SafeDep itself, on the repository. You will find that in demo client Java, and then you can simply clone it from here and then start using it or play around with it using dep, and then start vetting the libraries which are there. So I have sort of a setup here. I have installed this. I wanted to showcase one or two things to you before we jump into the actual scanning bit. So when you look at WET, there is one part of it. So for example, if you're just looking at the help for the tool, you will find essentially this is the pattern that it follows. You go with WET, you provide the options which are there, the actual command, and then the set of arguments of flags which are there. So the available arguments you can actually authenticate here. So auth is for authentication. You can configure that first. We'll be doing that right now. And then you can verify that. And then use others like completion, help, query, actual scanning and analysis, and then to show the version and build information, all of that. The flags you can use are debug, exceptions, log. This tool is still being developed, so it is still evolving, and there may be more such flags coming in. So we'll watch out for that. Now, once you've installed it, and for example, you also have to look something like this. And you should also have, for example, the library that you want to scan, or the path to the libraries or dependencies that you want to scan. Now that we already have here, let's quickly look at, if you're running it, there are two modes to run it. One is that you can configure the authentication using API key, which is highly recommended, especially for everyone doing that for production and having private repos. This is the way to go. But if you also are just trying it out and want to play around with it, you can also use a community mode and configure it with wet auth configure community. Once you have done the configuration, you will actually, once you configure, you will receive an API key. And that API key is what you have to set in the configuration. So you can actually verify that. For example, since I have done the wet auth configure, the key has been configured already. So you can simply just go and verify if everything is up and running with respect to the key. It will give you a signal saying that authentication key is valid, and then you can continue. So that's the way to go for most of us who are not just playing around it, but actually using it for development. Now the next part of wet is the scanning bit, which we will come to very quickly. Let's go back. So this is around installation and configuration of wet. Before we go to scanning, which is actually the basic part of, or the main part of the main engine of wet, which we will be looking at in this video, we'll only look at the basic ones. We'll look at the advanced ones, advanced features of wet, which are actually more interesting in the next video. So in this video, in wet, first it's important to understand how the architecture of the tool is and what it looks into, so that you can also build on the capabilities later once you have it. So this consists of, the wet tool as such consists of one, which is policy engine, one component. Policy engine is the basic policy engine where you can configure, design and define policies, for example, for your own organization or aligned with your own organization. And those policies, of course, will be written in the CEL, the Common Expression Language, which is what this policy engine understands. This one and then looks into two other components, which is insights and engine. So insights basically to get the insights for different languages, because it can scan and parse different languages packages to be able to, come up with vulnerabilities for those set of dependencies, which includes Go, Rust, Python, and Java, Ruby, and all of that. And there is the main engine. So this is the main engine for the tool. Engine is essentially, as we know, for dependency checking. The primary thing that it offers is, as of today, is that it can map your set of dependencies to the set of vulnerabilities, known vulnerabilities which are there, which of course it's collecting from various public DBs around where this information is already available, and refers to other places as well, like OpenSSF, Scorecard, OSV Dev, Deps Dev, and all of that. And the filters and query packs essentially aid in defining the policy. We'll look at this in more depth. These are essentially conditions that you can define based on which you can basically filter the outcome of the scan. So we'll look at this in the next video, but essentially all of these components together then are fed to, or can be fed to wet. So scanning and reporting, we will do the scan and see the results for ourselves. But one is to understand the format of the report that you get from wet. Essentially will give you the set of libraries to upgrade. Now, many of the tools that are available till date, you will find they will give you a list of dependencies and mapped vulnerabilities, and then you have to go ahead and figure out, what you want to upgrade or not. Here, the tool is slightly different in the approach, that it has to the person who's scanning. In this case, considering a developer or anyone from the development team gets or is running the tool, which is the expected way to go, you will find what are the libraries to be upgraded, which will reduce the impact to a greater extent. This is what we want to know. So which are those few libraries that I as a developer can upgrade so that the impact is reduced heavily? It maps that to the exact version to which I should, as a developer, upgrade this, and what is the impact that it will give. And you will see impact is in a descending order. So maximum impact package that you must upgrade for dealing with the rest of the vulnerabilities is, for example, in this case, Snake YAML, right? So accordingly, this is for demo client, but in your case, it might be completely different. And this is how you will find the other details as well. So I will show you these files afterwards, and we'll look into a bit of the analysis of the actual scanning as well. So let's look at the tool, wet scan. We're basically providing it the option for scanning, and then we provide the path to the directory. Right here, in this case, it is demo client Java, which is the set of packages that we have pulled in from SafeDep itself. Here you can have the actual path for the set of dependencies that you want to scan. And let's look at the results. I think that's all that we have to define. Okay, so this is now running. and it's scanning packages and manifests and all of that, and it'll give us the result. So it also tells you how much time it takes, which is good to know. So in the meanwhile, maybe we can look at you will see this is the composition of the demo client Java. There are, of course, libraries, but there are also manifest files like gradle.log file, other log files which are present. In the case of wet, it is important to have the log file. So whether it is npm, it is gradle or anything else, or maybe you should have the respective log file for it to be able to run. So in case it's not running for you, it'll be good to check that out. And as you would know, log file is essentially an index of all the dependencies that you're using in a project, and mapping that to the version of the dependencies that is being used. So yeah, this is the outcome that you will see. So in terms of outcomes, you'll see it is giving us 3 critical issues, 7 high and 8 other vulnerabilities that were identified. Details around, unpopular libraries. Now, one interesting thing about wet is that other places you will not see many engineering parameters being called out, but wet does call that out. So for example, if there are, to simplify this, if there are 2 libraries where both of them are of equal severity, so or upgrade first. One of them is not that popular or not that maintained, and can be vulnerable, can be upgraded first if that is needed. So you understand that popular, unpopular library, the ones that are maintained or not, how many people, how many contributions keep happening to those. The engineering parameters also play a relevant role when you're looking at how secure a dependency could be or couldn't. So here, it also calls those kind of things out. We'll see a lot of that when we define the filters later. And there are how many libraries are out of date. So all of those things are also called out here. The packages which you can upgrade to, and along with the recommended versions are all called out. So that is great about this. You can also change the way the report is. For example, if you use the same scan, we could also define that, okay, give us the report in a different format, like for example in a markdown format, and then call it maybe in this case, let's call it something else. Okay, so it will obviously it'll download that locally, and then here you can look at the results in a markdown format. And actually, yes. So let me maybe just cat one of these to show you how it looks like. This is how it looks. So this will start with your what is the manifest is considering, what are the ecosystem packages and things, how many packages are there, all the entire summary is given, and then how many of them actually need update. All that information is provided. And below that, you will also have policy violations. So the policies that we will define, which we will do in the next video, how many of those have been violated, and things like that. And then you also have the log file that has considered, and that is now then listed. Okay, so that's how the result will look like, and we'll go through in deeper depth in the next video, because this will then become longer. So looking forward to you all playing around with the tool, and yeah, let me know how you liked it, and we'll see you in the next video. Bye-bye.